Today we're going to look at how to solve exponential equations. This involves just a few steps. We're going to isolate the base. That's like what we've done before using the blob method. Once we've done that, we're going to convert it from an exponential equation to a logarithm. We're then going to solve for x if that's necessary. And last, we're going to use our calculator to get our decimal answer. When we do this, we're going to need to use something called a change of base formula. All that is, because I don't have on my calculator something with a special base if I have like a base of 5, so I need to change it to something that's on my calculator, like either log or natural log. And so I use something called the change of base formula, log base c of a over log base c of b. All this means is if I have something like log base 2 of 7, I could rewrite that as log of 7 over log of 2. Or if you want to do natural log of 7 over natural log of 2. This is true for any base, but we go with log or natural log because that is something on our calculator. So in my first problem, I already have the base isolated. That's it on one side, so now I'm going to rewrite this as a log. Log base 4 of 14 equals 3x. And if I look at the right side, how do I normally solve something like that? I would divide by 3. So divide by 3. And this is called our exact answer. So now I need to go from my exact answer to my decimal answer. So first I'm going to find, and I don't usually write out every single one of these steps, but I'm going to today. I need to find log base 4 of 14. So what I'm going to do on my calculator is do log 14 divided by log 4. Once again, you could use natural log if you would like as well. So I type that on my calculator, log 14 divided by log 4. Make sure that you close your parentheses after the log. So right here, there's going to pop up parentheses. Make sure you close this. And I get 1.904. Let's do 3 decimal places. So do that and press enter on your calculator. And now my next step is going to be this whole divided by 3. So on my calculator, I'm going to do divide by 3. And I get x equals 0.635. Now usually I would go straight from this answer to this last line. Okay, I'm just trying to show what I'm typing in the calculator. So if I look at the next problem, it's already isolated the base. So log base 2 of 9 equals x minus 5. And then what do I need to do to get x by itself? We're going to add 5 to both sides. So log base 2 of 9 plus 5 is my exact answer. I'm going to use change of base formula, so I'm going to type log 9 divided by log 2 in my calculator. Log 9, close your parentheses, divided by log 2, close your parentheses, enter. So I get 3.1699 plus 5 equals x. So 8.1, when we round, that would be 70. So what do I usually see? This line and this line. What's really important is that after you do your change of base formula, press enter. After I do each step of my operation, press enter to make sure my order of operations stays correct. Alright, finally when we need to isolate. So basically, like we did when we were solving radical equations, we blob up our base and the exponent. So how do I get my blob by itself? I'm going to add 3. So I get 3, 7 to x minus 1 equals 9. And then I'm going to divide by 3 because we're trying to get this blob by itself. So I get 7 to the x minus 1 equals 3. So my base is isolated. Rewrite it as a log. Log base 7 of 3 equals x minus 1. And we want to solve for x by adding 1. So log base 7 of 3 plus 1 equals x, and now we're going to type it in the calculator. Log of 3 over log 7 plus 1 equals x. Log 3 parentheses minus log of 7, close your parentheses, enter, plus 1, enter. Between every operation, press your enter button. Alright, so next problem, I still need to isolate my base, so we're going to minus 11. So 4 times 3 to the 2x minus 7 equals 14. This one doesn't divide evenly. Once again, we're trying to get our base by itself, but that's okay. So now we have the base by itself. We rewrite as a log base 3 of 3.5 equals 2x minus 7. If I look at just the right side, what are my two steps I need to do? I'm going to add 7. And then I'm going to divide by 2. You need to make sure for this part that we do enough steps on the calculator. So listen to how I say we're doing that. So I need to do, first of all, my change of base to do this. So log 3.5 divided by log 3. Enter. What was the next step we did? Add 7. So plus 7, enter. Then what did we do? Divide by 2, enter. Enter, enter, enter. Make sure you don't miss that. So x equals 4.070. Okay, next one, first step is to get my base by itself. So I would do that by dividing by -2. And I get 6 to the 4x equals -4. Well, is there anything that I can raise to an exponent and get out a negative? No. So, since that's negative, it means we're going to have no solution. For this one, we're going to blob it and then add 8 to both sides. So we get 2 to the x plus 4 equals 15. Rewrite as a log. Log base 2 of 15 equals x plus 4. How do I solve for x? We're going to minus 4. And now we're going to use change of base. Log 15 divided by log 2, enter, minus 4, enter. So I got -0.093. For this last one, if I think about trying to rewrite it as a log, it gets a little bit complicated. Why? Because both of these have a base and an exponent. So I have two different bases with exponents. So we're going to do something a little bit different for these. What we're going to do is we're going to do log of both sides. So you know, like how you would add something to both sides? Well, we're going to do log or natural log of both sides. These are the longest type we'll do with exponential, just FYI. All right, now what we're going to do, now that I have the log of that, I'm going to use my log property that if I have an exponent in the argument of my log, that could come forward and be written as multiplication in front of my log. So now that will give me 2x minus 5 times log 8 equals x plus 1 log 5. And the 8 and the 5 are my argument. They're not my base. My base on these is 10. Now we're going to distribute the log on both sides. So I get 2x log 8 minus 5 log 8 equals x log 5 plus log 5. All right, You may remember from inverses where we did the getting the y terms on the same side and factored out the y. Well, we're going to do the same idea, but we're going to get the x terms on the same side. So if it has an x, I underlined it in yellow, and I'm going to get those on one side. So I have 2x log 8 minus x log 5, and then the other stuff is going to move to the other side. So 5 log 8 plus log 5. Now they both have an x, so I can factor out x, which leaves me with 2 log 8 minus log 5 equals 5 log 8 plus log 5. So I have this written as multiplication, so what can I do? I can divide by this horrible hot mess. All right, so actually now we're at the step we could type it in our calculator. But when you type this bad boy in the calculator, you need some like massive amount of parentheses. So you need parentheses around the entire numerator and parentheses around the entire denominator. But remember, your calculator is going to automatically add this first parentheses when you type stuff in, so you need to make sure you're closing that every time. Okay, so I put where the calculator will start kind of inputting things. So we type that whole thing with a bunch of parentheses, 5 log 8, close little parentheses, plus log 5, close little parentheses, close big parentheses, divided by parentheses, 2 log 8, little parentheses, minus log of 5, little parentheses, big parentheses. When I do all of that, I get that x equals 4.7 when we round 10.